Welcome. Today, we're unpacking Kotlin classes. Whether you're a complete beginner or an experienced dev polishing your skills, mastering the different types of classes is a total game changer. We'll break down regular classes, data classes, constructors, and more using simple real-world analogies and clear examples. By the end, you'll know exactly how Kotlin structures code and why these differences matter. Let's kick things off by comparing regular classes and data classes. Regular class in Kotlin acts as a blueprint for creating objects. These objects can have both properties, which store data, and functions, which define behavior. Think of a regular class like a smartphone. It has data such as battery life and storage, but it also performs actions like taking photos or connecting to the internet. Regular classes are versatile and can be customized to fit many needs, making them the foundation of most Kotlin programs. Data class is a special kind of class in Kotlin, designed specifically to hold data. Unlike regular classes, data classes focus on storing information rather than defining complex behaviors. Imagine a business card. It simply holds your name, phone number, and email, but doesn't do anything else. When you declare a class as a data class, Kotlin automatically generates useful methods like toString, equals, hashCode, and copy, making your code cleaner and more efficient. Let's compare a regular class and a data class with a simple example. Suppose you have a user class and a DataUser data class, both with the same properties. When you print a regular user object, you'll see a memory address, but printing a DataUser gives you readable information. Plus, with data classes, you can easily create copies with slight changes using the copy method. This feature is especially handy when you need to manage immutable data. Structors are special functions used to initialize objects when they're created. In Kotlin, there are two main types, primary and secondary constructors. The primary constructor is part of the class header and initializes the main properties. Secondary constructors, declared inside the class body, offer alternative ways to create objects, often with different or fewer arguments. This flexibility allows you to handle various initialization scenarios with ease. Primary constructor in Kotlin is straightforward and concise. It's defined right in the class header and is responsible for initializing the main properties of the class. You can think of it as buying a standard, fully built house directly from the manufacturer. Everything you need is included from the start. Each class can have only one primary constructor, ensuring a clear and consistent way to create objects. Secondary constructors provide alternative ways to create an object. They're declared inside the class body using the constructor keyword. These constructors must delegate to the primary constructor, ensuring that all essential properties are initialized. Imagine buying a modular home, but requesting a custom payment plan or omitting the garage. Secondary constructors give you that flexibility while maintaining the core structure. Let's look at an example. The employee class has a primary constructor for name and role, and a secondary constructor that allows you to create an employee with just a name, defaulting the role to intern. This approach makes your code more flexible and user-friendly, accommodating different ways to create objects while keeping your logic organized. Primary constructor in Kotlin can't contain code, so if you need to run setup logic or validate input when an object is created, you use an init block. The init block runs automatically right after the primary constructor. Think of it like a smart fridge's startup sequence. When you plug it in, it checks coolant levels and calibrates temperature before you start using it. The init block ensures your object is ready for action. Consider a bank account class with an init block. When you create a new account, the init block checks if the initial deposit is at least $100. If not, it throws an error. This ensures that every bank account object starts in a valid state. The init block is perfect for enforcing rules and running setup code right when your object is created. Kotlin uses the philosophy of closed by default to protect your code. By default, classes and methods are final, meaning they can't be subclassed or overridden. If you want to allow inheritance, you mark them as open. Abstract classes, on the other hand, act as templates and can't be instantiated directly. They force subclasses to implement their abstract methods, ensuring a consistent contract across your code. Final class or method is locked and cannot be changed or inherited. This is the default in Kotlin, preventing accidental modifications. Imagine a brand new iPhone. It's sealed and you can't alter its internal hardware. Final classes are perfect when you want to guarantee that your code remains unchanged and secure. Marking a class or method as open unlocks it for inheritance and overriding. Think of a Jeep Wrangler. It's designed so you can remove doors, swap the roof, and customize it. Open classes are great when you want to provide a base for others to build upon, allowing for flexible and extendable code. Abstract class is like a blueprint for a house. You can't live in the blueprint itself, but you can build a real house from it. Abstract classes can't be instantiated directly and require subclasses to implement their abstract methods. This ensures that every subclass provides its own version of the required functionality, maintaining a consistent structure. See these concepts in action. An abstract shape class defines a method for calculating area but doesn't provide an implementation. The open circle class inherits from shape and provides its own version of calculate area. Finally, a regular class like antique circle is final by default and cannot be subclassed. This structure keeps your code organized and predictable. Sealed class in Kotlin represents a closed, restricted hierarchy. It's like an enum on steroids. While enums are limited to single instances, sealed classes allow subclasses with their own unique states. This is perfect for modeling scenarios where a value can only be one of a limited set of types, but each type might hold different data. Imagine a delivery package that can only be in one of three states: in warehouse, out for delivery, or delivered. Each state might carry different information, like the delivery driver or timestamp. Sealed classes let you model these states safely, ensuring your code handles every possible case without surprises. The network result example, the sealed class has three possible types: success, failure, and loading. Each type can carry its own data, like a result string or an error message. When you use a when expression with a sealed class, Kotlin ensures you handle every possible case, making your code safer and more robust. Enum class represents a fixed set of constant values. Unlike sealed classes, each enum constant is a single instance and doesn't hold unique architectural states. Enums are perfect for modeling things like the four cardinal directions or traffic light colors, where the set of possible values is known and unchanging. Think of enum classes like traffic lights, red, yellow, and green. There will never be a fourth traffic light color in standard rules. Enum classes are ideal for representing a closed set of options, making your code clear and easy to maintain. In the traffic light enum example, each constant, red, yellow, and green, has an associated action. When you use an enum, you know exactly what values are possible, and you can attach properties or methods to each one. This makes enums a powerful tool for managing fixed sets of related values. In Kotlin, the object keyword is used to implement the singleton pattern. When you declare an object, Kotlin ensures that only one instance exists throughout your application. This provides a global access point, making it easy to manage shared resources. Think of it like the Earth's moon: there's only one, and everyone interacts with the same instance. Consider the database manager object. You don't need to create an instance, just access it directly by name. This ensures that all parts of your code use the same database connection, preventing conflicts and making your application more reliable. Object declarations are perfect for managing singletons like configuration managers or logging utilities. Companion object is an object declared inside a class. Its members can be accessed directly using the class name, just like static methods and properties in Java or C. Companion objects are great for binding utility functions or constants to a class without needing to create an instance. They act as a shared factory stencil for the class. The userCount class, the companion object, holds a constant for maximum login attempts and a factory method for creating admin users. You can access these directly through the class name, making your code cleaner and more organized. Companion objects are ideal for grouping related utilities and constants together. Interface in Kotlin defines a contract, a set of behaviors that a class must implement. It tells you what an object can do, but not how it does it. Unlike classes, a class can implement multiple interfaces, allowing for flexible and modular design. Interfaces are essential for defining reusable and interchangeable components. Think of an interface like a USB port contract. Your laptop doesn't care if you plug in a mouse, keyboard, or flash drive, as long as the device follows the USB interface rules. Similarly, any class that implements an interface must provide the required methods, making your code more flexible and adaptable. In the playable interface example, both audio player and video player implement the play method. Each class provides its own version of play, allowing you to use them interchangeably wherever playable is expected. This approach promotes code reuse and makes your applications more modular. Kotlin interfaces can have default method implementations. This means you can provide a standard behavior that implementing classes can use as is or override with custom logic. This feature makes interfaces more powerful and reduces boilerplate code, giving you the best of both worlds. Imagine a rental apartment contract that comes with a default paint color, off-white. You can keep it as is or request permission to repaint it. Similarly, Kotlin interfaces let you use default methods or override them for a custom look and feel. This flexibility streamlines your code and enhances maintainability. In the logger interface, loginfo has a default implementation that prints an info message. The console logger class only needs to implement log error, but it automatically inherits loginfo's behavior. This reduces repetitive code and lets you focus on what's unique to each class. You've covered the main types of classes in Kotlin: regular, data, sealed, and enum classes, as well as object and companion objects. Each serves a unique purpose, from holding data to managing singletons or defining fixed sets of values. Understanding these types helps you write clearer, more maintainable code. Constructors, both primary and secondary, allow you to initialize objects in flexible ways. The init block provides a place for setup logic and validation, ensuring your objects start in a valid state. These tools give you control over how your classes are created and used. Kotlin's open, final, and abstract keywords let you control inheritance and extension. By default, classes are final, but you can open them for extension or make them abstract to enforce a contract. These modifiers help you design robust and predictable code architectures. Sealed classes are perfect for modeling restricted hierarchies with unique states, while enum classes represent fixed sets of constants. Both help you manage your code's possible values, making it safer and easier to maintain. Object declarations implement the singleton pattern, ensuring only one instance exists. Companion objects provide static-like members tied to a class, making it easy to group related utilities and constants. These features simplify resource management and code organization. Interfaces define contracts for behavior, supporting multiple implementations and default methods. They promote code reuse, flexibility, and modular design. Mastering interfaces is key to writing scalable and maintainable Kotlin applications. In designing your classes, choose the type that best fits your needs. Use data classes for simple data holders, sealed classes for restricted hierarchies, and enums for fixed sets. Leverage object and companion objects for shared resources, and interfaces for defining reusable behaviors. This approach leads to cleaner, more maintainable code. Careful not to overuse inheritance or create overly complex class hierarchies. Stick to composition and interfaces where possible. Also, remember that data classes are not meant for classes with significant behavior. Use them only for holding data. These best practices help you avoid common mistakes and keep your codebase healthy. Use regular classes for objects with both data and behavior. Data classes are ideal for simple data containers. Sealed classes shine when you need a closed set of types with unique states. Enum classes are best for fixed options. Object declarations manage singletons, and companion objects group static-like members. Interfaces define what your objects can do, not how. Real-world projects, you'll often combine these class types. For example, you might use data classes for API responses, sealed classes for representing network states, and interfaces for defining common behaviors across different modules. Understanding how and when to use each type makes your code more robust and easier to maintain. Kotlin's design encourages clarity, safety, and expressiveness. By making classes final by default and providing powerful features like data classes, sealed classes, and default interface methods, Kotlin helps you write code that's both concise and reliable. Embrace these features to get the most out of the language. Let's quickly recap. Regular classes combine data and behavior, data classes hold information, sealed and enum classes manage restricted sets, object and companion objects handle singletons and static-like members, and interfaces define contracts. Each has a clear role in Kotlin's ecosystem, making your code more organized and effective. Now that you understand the different class types in Kotlin, try applying them in your own projects. Experiment with data classes for simple models, sealed classes for state management, and interfaces for reusable behaviors. The more you practice, the more natural these concepts will become. Thanks for joining this deep dive into Kotlin's class types and features. With these tools, you're well equipped to write clean, efficient, and maintainable Kotlin code. Keep exploring, keep coding, and enjoy the journey as you master Kotlin's powerful class system.